Okay, hey everybody, hope you're doing awesome today. Sorry I can't be with you, but we're still going to go through everything that we usually do. When I'm there, it'll just be like I'm in surround sound in your earbuds. So hopefully all is well today. For a lot of you, this might be something new that you've never done before. And here's a couple tips for you. So one, if you need to take a short brain break because I'm talking way too much or things are confusing and whatnot, and you need to rewind and watch the video again, do that. All right. Secondly, take good notes. Remember, if I'm writing something down here on the screen, probably a good idea for you to have it on your paper as well. Okay, so give me a great effort today. Hopefully things aren't too terribly complicated. We're going to talk about cube roots and square roots today. So I know we've been talking a lot about square roots, and now we're going to introduce kind of like their twin, right, called cube roots. Anyway, we're going to start out our day, as most of them will be. This is our warm-up here. So this warm-up is going to be on page 25. So let's take a listen.
Matt and his dad are building a tree house. They buy enough flooring material to cover an area of 36 square feet. What are all the possible dimensions of the floor?
Okay, so we're tasked with figuring out the possible dimensions of the floor. I mean, do you think there's only one dimension that will work for this rectangular, 36 square foot floor? I'll give you a clue. The answer to that is no. No, there's not. So how are we going to figure out maybe what one or two of these possible dimensions might be? So go ahead, pause this, try to figure out as much as you can, and then when you're done, come back and we'll talk about it real quick. Okay, so hopefully you've got some ideas on some possible dimensions. Basically, what we're looking for are factors, right? I want to find all the factors of 36 because those could all be possible dimensions, right? We could have an area that's 1 foot by 36 feet, right? That would give me an area of 36 square feet. How about 2 feet by 18? How about 3 feet by 12, right? How about 4 feet by 9? Or, of course, 6 feet by 6. So these are all of our possible dimensions right here. Hopefully you came up with one or two, or heck, you might even came up with all of them. So go ahead, and we're just going to run through all the examples now. All right, be a good listener, and again, take good notes. Okay, so here we go. Off to example number 1 about a birdhouse.
How do you evaluate cube roots and square roots? Think about this question during the lesson. Leah is building a birdhouse for purple martins, birds that prefer cube-shaped birdhouses. She wants to know the dimensions of each square piece of wood she needs to build the 216 cubic inch birdhouse. What do you know about the length, width, and height of the birdhouse?
Okay, so, think about here, what is volume? What does it mean in terms of this birdhouse? So remember, volume is just the amount of space inside a figure. For this one, that just means, hey, this is the amount of space that's inside the birdhouse. Okay, now, be a good reader. It says she's going to build a cubic or a cube-shaped birdhouse. Why is that important? Well, a cube has the same dimensions, right? So length and width and height are all the same dimension. So in other words, we've got some number, right? We've got the same number 3 times, and length times width times height equals our volume. So let's maybe remember that as we continue on to watch our video here.
The length, width, and height of a cube are all equal. We can draw and label this cube to represent the birdhouse. Leah needs a volume of at least 216 cubic inches. The length, width, and height are all equal. We'll label the sides S. The volume is equal to S times S, or S cubed. A number that is a cube of an integer is a perfect cube. The number 216 is also a perfect cube. Which of the following is also a perfect cube? Select your answer.
Okay, so in other words, 4, 6, 64, or 256, one of those will also be a perfect cube. Just like we had perfect squares, right, like 4 and 9 and 16 and 25, we also have perfect cubes, all right? We'll be able to use our calculator to help us figure out what perfect cubes are, but they're very similar in that when we go to determine if a number is a perfect cube using our calculator, one of two things happens. The first thing, we get a nice whole number, or the second thing, we get a terrible, awful, very bad, irrational number. Okay. However, of these 4 ones that they have here, only one of them happens to be a perfect cube, and I believe that to be 64. So let's carry on.
This symbol means the cube root of a number. The cube root of 216 is equal to the cube root of 6 times 6 times 6, which equals the cube root of 6 cubed. Taking the cube root and cubing a number are inverse operations. So the cube root of 6 cubed is equal to 6. The dimension of each square piece of wood is 6 inches by 6 inches.
All right, so this one says, hey, find the cube root of 1,000, right? Again, I'm going to show you here in just a second when we get to the try it, how do we put that into our calculator. But basically 10 cubed, or 10 times 10 times 10, really does equal 1,000.
Are there other dimensions that would give a volume of 216 cubic inches? If so, are they answers to this problem? There are other dimensions of a rectangular prism that give a volume of 216 cubic inches. However, only one set of dimensions makes a cube. So there is only one answer to this problem.
A cube-shaped art sculpture has a volume of 64 cubic feet. What is the length of each edge of the cube?
Okay, so here's how we can use our calculator to help us with cube root. So grab out your calculator, and I want you to look for the button in yellow that, here, I'll even write in yellow. It's got an X, and then it's got the little square root symbol. And you'll find that above the little caret, which is above the X squared button, right? Look right above that. Okay, so if I want to find the cube root of, in this case, say 64, here's all you have to type into your calculator. We need to tell the calculator, first off, what number it wants us to find the root of, because you could find the 4th root or 5th root or 10th root of a number, but we're just only going to deal with square roots and cube roots, right, in 8th grade. So we need to put the number 3 in first. Then you've got to hit your second button. Then you're going to go hit the X root, right, button, and then you're going to type in whatever number you want, right? In this case, we're going to type in 64. When we do that, here's what you should see on your calculator screen. It should look just like that. And your calculator is figuring out for you what number multiplied by itself, times itself, right, 3 times, will give you 64. Again, one of two things happens. We get a whole number, like we do in this case. We get the number 4. or you would get a really bad number, right? Everybody go ahead, take the square, or the cube root of, let's just say, 75. So if you take the cube root of 75, right, and see what that turns into, it's not a good number, right? That turns into 75, right? That turns into like 4.217 and a whole bunch of other stuff. So again, really good number, whole number, or in this case, you're going to get the other thing that could happen. You get a bad number, an irrational number. Okay, so that's how we can use our calculators to help us with perfect squares, just like we did, perfect cubes, just like we've done with perfect squares. Okay, on to example 2. Again, example 2, very straightforward.
Evaluate the roots.
So again, we're just figuring out here, is 64, 49, 100, 8, are they cube roots, right? What is it? Take the square root of it. All of these turn into great numbers here. So these are all perfect cube roots, like we see with A and D, or perfect square roots, like we see with letters B and C. So again, hopefully you feel a little bit more comfortable with how to enter those into our calculator. And let's look at the try it here that goes with example number 2. Again, here's just a little bit of practice that we can do on our own. So A and D are finding cube roots, B and C are square roots. So go ahead, pause this, figure out what those 4 numbers are in disguise, right? The cube root of 27 really is a number in disguise. Let's figure out what it is. Same with B, C, and D. So pause it, write your numbers down. I'll give you the answers here in just a sec. Okay, hopefully you're back. Letter A, right? Answer to the cube root of 27 is 3. B, the square root of 25, of course, 5. C, nothing hard here. The square root of 81 is 9. And D, the cube root of 1 actually is 1. Okay, so that was easy enough. Let's move on to example 3. We're in the home stretch here. Stay with me.
Sean cuts one sheet of colorful poster paper to cover the bulletin board exactly. What are the dimensions of the poster board that will cover the board exactly?
Okay. Anybody know why Sean is using the square root of 144 to figure this out instead of the cube root of 144? Like, why did we pick the square root? Well, remember, Sean's finding the area of the square bulletin board, right? He's finding area, not volume. Area says one side times another side, right? It's not volume like we saw with the birdhouse problem. That's why we're using square root. So we need to make sure we're using the right root, right? Whether that's the square root or the cube root. But once we find that out, it's really just as simple as, hey, yep, here we go. Take the square root of 144. And there's your side length, right, for each side of this bulletin board. And the locker's got to be a 12-inch by 12-inch piece of paper. Okay, let's take a look at the try it that goes with example number 3. Here we go. Okay, so this one's all about Emily, and she wants to get a tablecloth to cover a square card table. So here is her imaginary square card table. And we know the area of this is 9 feet, right? So here's her card table. Area says, hey, this dot over here times this dot, right, has to equal 9 square feet. Well, in order to figure out what that number is, I just need to take the square root of 9, right? And I know they've given this away here, but we just need to figure out, hey, what are we dealing with? Yeah, of course, we all know the square root of 9 is just 3 times 3, which means, hey, she has to get a tablecloth that is at least 3 feet by 3 feet. Okay, so now we're going to go ahead and move on to my favorite page, of course, the key concepts page. So that's going to be on page 28. So we will hop over to that here, hopefully just in a second, and we can work on that together. Look, here we go. It's like I'm here, but I'm not here. Yeah, no bad jokes today, though, so it's not Joke of the Week Friday. Again, there's your key concepts up at the top there about cube roots and square roots. All right, and our first question is right here. All right, and it wants to know, how do you evaluate cube roots and square roots? Well, I could show you the long, drawn-out, boring way to evaluate cube roots and square roots, but that would be miserable. So for now, how do we evaluate them? So let's use our calculator, right? Remembering, when we find a square root, that's really just some number times that same number. When we're finding cube roots, right, it's really some number times the same number times, the same number, right, 3 times to give us that cube root, all right? Let's take a look over here at 4. If a cube has a volume of 8 cubic inches, what is the length of each side? So remember, let's draw our best cube over here. That's not my best effort, but it's not too bad, I don't think. Okay, what do we know about the volume of a cube? Right, the volume of a cube. Remember, volume of the cube says, hey, this green edge right here times this edge right here times this one right here has to equal 8. But it's always the same number because it's a cube, just like squares. All the sides are the same. Cube, same thing, right? All the sides of that cube are the same length. So I merely just want to take the cube root of 8. All right, so you guys do that. Throw that into your calculator, cube root of 8. There's your answer, right? What does it happen to be? Happens to be 2. Remember, one of 2 things happens. We get a nice whole number, like we did here, or we'll get a terrible irrational number. Okay, let's move on here to 2 and 5. Okay, so we'll scroll up here, maybe, hopefully, in a second to questions 2 and 5. Here we go. All right, question 2. A certain number is both a perfect square and a perfect cube. Interesting. Will its square root and cube root always be different numbers? Explain. Okay, this is kind of like a tricky question, and here's why. There is only one number that I can think of, that I know of, right, that is the same. When I figure out what its perfect square and perfect cube is, it's the same number, right? And that happens to be with our good friend 1. If you find the square root of 1 or the cube root of 1, well, both of those equal 1, right? So 1 is a perfect square and a perfect cube. It's kind of crazy. For every other number, right, the square root and the cube root will always be different, right? So unless you're 1, right, you're the same number. But here, for all others, the square root and cube root will be different numbers. Different numbers. Okay. All right. Let's take a quick look at question 5. Here's a model of the infield of a baseball stadium. How long is each side of the infield? Okay, so we're really just focused on each side of the infield, right? There's one side, here's another side, here's another side, right? So we've got 4 sides of this infield, and we just have to figure out how long each side is. Well, it tells me that the area is 81 square inches. So if area of a square is 81, that means 2 side lengths multiplied together would give me 81. So this is a find the square root of 81. Again, once we know that part, this problem becomes easy because the square root of 81 is just 9. So on this model, each side of the infield is 9 inches. Okay, let's scroll down here to 3 and 6. Okay, I'm hoping it scrolls down here any second. There it goes. Okay, question number 3. A cube-shaped box has a volume of 27 cubic inches. Again, draw your best cube-shaped box. Bethany says each side of the cube measures 9 inches because 9 times 3 is 27. Is she right? Okay, well, I'm going to draw a cube. Hopefully you have already drawn your cube. Here we go. There's the cube. Optimus is happy because I have it, and I won't give it away to the bad people. If you haven't watched Transformers, that made no sense. Anyway, Bethany says each side of this cube is 9, right? So in other words, that side is 9, and this is 9, and that's 9. And it tells us a cube-shaped box has a volume of 27. So remember, volume, right, is length multiplied by width multiplied by height. And if what Bethany says is true, right, if every side is 9, then that means the length 9 times the width 9 times the height 9, right, is what the volume is. Well, if you take 9 times 9 times 9, gang, I believe that to be 729, okay, which is clearly not the same volume that they told us it was. So Bethany is wrong. She just said, hey, if there's 3 sides and they're all the same, 27 divided by 3 is 9, but that doesn't work, right? Really, we want to take the cube root of 27, all right? The cube root of 27, go ahead and put that into your calculator, right? Some number times itself, right? 3 times is 27. That, of course, is 3. So 3 is the right side length, right, for this cube, not 9. Okay, last one. Julio cubes a number and then takes the cube root of the result. He ends up with 20. What number did he start with? Okay, so in other words, Julio cubes a number, so he takes some random number and he multiplies it, right, by itself, right, 3 times. Then he takes the cube root of that, and he ends up with 20. What number did he start with? This is like a trick question, guys. If I tell you, hey, take the number 20 and multiply it, right, by itself, right, or cube it, right, there's 20 cubed. That's what that looks like, right? Here's what it, exponents, just repeated multiplication. 20 times 20 times 20, all right? That's a pretty big number, but you guys can handle that. So 20 cubed, right, is actually, I think, 8,000. My mental math power is correct. Then if I take the cube root of this number, so I take 8,000 and I take the cube root of that, well, that turns out to be 20. Right? So remember, cubing a number, right? Cubing a number and taking the cube root of a number, those are what we call inverse operations, right? They undo each other. Kind of like when we did all that work with equations at the beginning of the year and we were undoing, multiplying with dividing or undoing addition with subtraction, right? Those are inverse operations, right? This is another pair of inverse operations that we'll use probably very soon to solve equations. So, again, if you need to rewatch any part of this, go ahead and do that. Okay, if not, I think it's time for us to get a little bit more practice. So let's get the additional practice, work on that. We'll go over that. Well, I won't go over it, but our sub will go over that right before class ends. And then as well, if we get done with that, we can also get going on our Math Excel too. So be a hard worker. I'll be back tomorrow. Everything will be great. But hope you guys have a fantastic rest of the day, and I will see you guys very soon.